Welcome to all. Now today's class I am closing this is the last question for inclined plane with just one block. Next connected bodies will come and some other questions will be there, but as far as inclined plane with a single block is last question. And class, it is a beautiful question. This will make the concept completely clear for you. Some logics are there. I will first solve the question and then see, I noted down the answer. Somewhere in the corner also, I noted down to save the time. Now, see, question is, a block weighing 6 kilonewton, this weight. See, here, I wrote here, as shown, peptide on the block, as shown in figure. So when they tell as shown, this sketch is given in the question. Remember, we are not prepared the sketch. It is given in the question. Or words also will do. See, a block weighing 6 kilonewton is placed on a rough inclined plane which makes an angle theta with horizontal. Now do one thing. There are 3 questions are here. I will tell you little later. Okay, I write now theta, this angle. They will tell theta later. Angle of friction is 40 degrees. That is angle of friction. A force P is applied on the block as shown. See, along the plane. Under, you can make out here, along the plane. It looks like little inclined actually. It is exactly along the plane. See, this way. A force P is applied on the block as shown. Now, what they want is find the range of P for which the block will be in equilibrium. For A, theta is 35 degrees. That is, solve this question taking theta 35 degree, first question, that is A. Question 48A. Then B, take theta equal to 40 degrees. That 40 is not this 40. This is given in the question. C, take theta equal to 46 degrees. Or you can prepare 3 independent questions. I will read the question if you want. See, a block weighing 6 kilo. See, question number 48. You make 48, but actually maintain the same question. 3 separate questions you write. See, question 48, write A here. A block weighing 6 kilonewton is placed on a rough inclined plane which makes an angle of 35 degree with horizontal. Here, in the sketch, mark 35 degrees. Okay, then question is over. Next question. A block weighing 6 kilonewton is placed on a rough inclined plane which makes an angle of 40 degree. Show 40 degree here. Write one more question. Last question, write 46 degrees. So here, theta is not unknown. It is given, but 3 questions are there. I will tell you why 3 questions. First, I will solve the question. Then, I will explain the concept. See, those who are interested in learning the concept, at the end I will explain. Okay, now, start. Find the range of P for which the block will be in equilibrium. You can make a note here. Block will be in equilibrium. Make a note. No, later I will write. Will be equilibrium. For theta 35 degrees, 40 degrees, 46 degrees. Consider 3 independent questions. Now, before I start solving, make a note. Solution. You have to solve 48A, then 48B and 48C. For all the 3 questions, see here. Common for all the 3 to save the time. They told angle of friction 40 degrees. This 40 is not this 40. It is angle of friction 40 degrees. Therefore, coefficient of friction mu equal to tan 40 equal to 0.8391. So, all these 3 questions mu equal to 0.8391. Or it is as good as telling, instead of giving angle of friction 40 degrees, it is as good as telling coefficient of friction equal to 0.8391. Okay, then let R be normal reaction. Every time it will come. In case of limiting friction, see, anyway, later you can make out. This question, everywhere, you can make a note here. In case of limiting friction, because in this question, all the calculation you write here will corresponding to limiting friction. Means in the bracket write. The body is either on the work job sliding down or on the work job moving up. Why I will tell you later. So everywhere limiting friction resisting frictional force FF limit equal to mu R. So FF limit equal to mu into R, 0.8391 R. This is common part. All the questions same. But now see, class, I will tell what is the range of P. Range of P means, you write here, to find the range of P, you add something extra here. I will dictate here. I will dictate, space is not there. Range of P, they can ask. Or, instead of asking range of P, see, you can make a note somewhere outside. See, you write range of P, put a star here. They can ask you what is the minimum value of P or maximum, and also maximum value of P. Range means minimum to maximum, or least value of P or highest value of P. That is called range. See, what is the range? For example, see, in a year, what is the range of monthly salary? January month, say, earning, somewhere earning, January month, 20,000, February month, 13,000, okay, 13,000. March month, 44,000, April month, 56,000, then April, May, up to June I will tell, half year, May, 80,000, May, 80,000, June, 66,000. So, least and highest earning is 13,000 I told in February and 80,000 in the month of May. That is a range. So, your range of income is 13,000 to 80,000 in the 6 months. Why till 12 months? Range. Suppose, see, so that means every answer is either equal to, sorry, all the values are in between, all remaining values are in between 13,000 and 80,000, that way. So, asking to get the range of P for the block to be in equilibrium means asking to find the least, you write here, see, no space to write, least value of P and also highest value of P for which this block will be in equilibrium, or other language, those who are serious, minimum value of P and maximum value of P for which this block will be in equilibrium. Equilibrium means should not move. But remember, it can be the verge of moving. See, verge of, make again note, it should not move. It should be at rest. But critical case is possible. Either on the verge of moving, either moving down or moving up will come later. So, verge of moving is okay. Still not moved, but it should not move. So, equilibrium means body should not slide down and also body should not move up. Write all the statement. Case 1. See, now, see, this is the problem. See, now, after writing all this, you write here. See, what we have to do. Right here, what we have to do. We have to consider 2 cases. They want the minimum value of P and maximum value of P, or range of P means we have to consider 2 cases and find the value of P for both the cases. Case 1 is when the block is on the verge of sliding down the plane. On the verge of sliding down the plane. That is, you have to find what value of P is, see, you can write here, or block is on the verge of sliding down means what value of P is required, you write here. So, that just to prevent it from sliding, right here. And second case, when the block is on the verge of moving up the plane, means when the body is on the verge of moving up the plane means what? What force is required to move the block up the plane, or at what force the body is on the verge of moving up the plane. Once again, find. These two are minimum and maximum values of P for equilibrium. So, if the P value is anywhere in between these two, the body will be in equilibrium. Anyway, right here. After solving all A, B, C, after solving A, B, C, see, A, B, C, 3 questions and getting the answer, I will rub out everything here and give you complete logic. I will make the concept fully clear. So first wait for some time. Okay, now start. Question 48a is theta is 35 degrees. So okay, mark here. 35 degrees. If that is 35, this is 55. X like this, y like this. And consider case 1. See, consider case 1. That is, find the value of p. That is, find the value of p. Not that is, when, see, find the value of p. Case 1, okay, p, when, actually not required, when block is, oh, space problem, block is on the verge of sliding down the plane. Okay, see, little problem space here. Case 1 is find the value of p when the block is on the verge of sliding down the plane. See, how much p? Sliding down the plane, so friction is like this. This you know it. This if I explain, it will be waste of time. Okay, start. Put the sketch. Now, I will give fast answer. Now, these all, you should do it. See, so many questions are solved. If you cannot solve now, helpless. So, I will dictate sigma fy0 plus r minus 6 sine 55 equal to 0, 6 into sine 55. Calculator is not on. 6 into sine, 6 into, I got the answer there. I am checking the answer. 6 into sine 55 is r equal to plus 4.9149. Okay, I wrote here 4.9149. Sigma fx0, see, plus p, right side, this way positive, plus p plus 0.8391 r minus 6 cos 55 equal to 0. Substitute that r value, you will get p. That p will come 4.9149 into 0.8391, that is the answer, p, that you subtract from 6 into cos 55, minus 0.683. Oh, minus value came. I will explain why minus. Okay, then, this is case 1. See, every problem twice you have to solve. Now consider case 2 and find the value of phi when, see, find the value of p, I let here, when the block is on the verge of, verge is clear? Can you hear? Actually, you know, I am telling verge like that, on the verge of moving up the plane. Surely you require more effort now. Okay, start. Now remember, block is on the verge of moving up, so friction is down. P is there. This is not that P. As usual, P this way. See, P this way. Okay, start. Sigma fy0 plus, now see, here body is on the verge of sliding down, friction is this way. Here body is on the verge of moving up, friction is this way, reverse. Okay, plus r minus 6 sine 55 equal to 0, r will again come plus 4.9149, and then sigma fx0, take this side positive, plus p minus, see, last time it was plus p plus, now it is plus p minus 0.8391 r minus 6 cos 55 equal to 0, you will get 4.9149 into 0.8391 plus 6 into cos 55 equal to 0, 7.567, yes, 7.566 plus 7.566, right here. Therefore, right here, answer, everything is over. Therefore, black I will write for equilibrium of the block, for equilibrium of the block, the range of P, see, space is, I don't know whether the range of P, range of force P is, I write the answer, minus 0.683 to plus 7.566 kilonewton. I think I have gone too much below the camera. Problem comes. No, it's okay, visible. So the range of P is, I write a black color only, because if I put red color, it will not be clear. Okay, I will use black color only. The range of P is how much? Range of P is minus 683 kilonewton to plus 7.566 kilonewton is the answer. Right here. At the end, after finishing all the questions, he will explain logic and concept in the full board. This full I will remove, and I will explain what is the meaning of this negative, what is the meaning of this positive. I will explain. Or least value of P, highest value of P. You can make a note here. In the question, if they ask you, find the least and highest value, this is the least value, this is the highest value. This is question 48A over. I will change over to question 48B now. I will change the values. Before I explain, I will change the values. Now, question 48B. See, 48B is here. I noted the answer here. Theta is 40 degrees. Oh, started raining. Okay. Theta 40 degree means actually this is the case when theta equal to angle of friction. If you remember something, the body is already on the verge of sliding down. Therefore, see, answer came 0. Okay, that all I will tell at the end of the class. Start. You solve naturally. Theta equal to 40 degrees. See here, 40 degrees. So little more. See, I don't want to change the sketch actually. Make little more stiff. 40 degrees. This is 50 degrees. Now, same thing. First, consider the case 1 and find value of P when block is on the verge of sliding down. Okay, friction is this way. Everything same. Sigma Fy 0. Why should I unnecessary? Last I will tell. Plus R minus 6 sin 50 equal to 0. R will come 4.5963 kilonewton. This you have to solve. Sigma Fx 0. Right side this way positive. Plus P plus 0.8391 R. Substitute this R. Minus 6 cos 50 equal to 0. Your P will come 0. Actually 0 will not come. In the calculator I got 0.00002 because tan 40 is not 0.83. Where is the tan 40? See, when you calculate tan 40, it is, I wrote 4 decimal 0.8391. If you want really to get perfectly 0 here, you have to write tan 40. See, tan 40 is 0.8390996312, that much not required. Or whenever you do a problem, when you get answer 0.000 something means it should come to the mind, oh, because of approximation it happened, answer is 0. So P is 0. Then consider the case 2. Find the value of P when the block is on the verge of moving up. Only change is friction reversed now. See, sigma Fy 0 plus R, then minus 6 sin 50 equal to 0, R will come 4.5963. Sigma Fx 0 plus P, see last time plus P plus, but this time plus P minus 0.8391 R, then minus 6 cos 50 equal to 0, P will come plus 7.713 kilonewton. Right. Therefore, for equilibrium, the range of P is 0 to plus 7.713, or minimum value of P is 0, maximum value of P is 7.713 for equilibrium, or the least value of P for equilibrium is 0, and the highest highest value of P for equilibrium is 7.713 positive. Okay, over. Now, this is also over. I will go to 48C. When theta equal to, last question, 46 degrees. 46 degrees. Now, I should make little more stiff. Okay, scale is not there. See, this is 48 degrees. If that is 48, this angle will become how much? 42 degrees. Be careful. If it is 46 degrees, sorry. Theta is 46 degrees. When this is 46 degrees, this angle will become 44 degrees. Be careful. Okay, I will solve now only. Now I will not explain. Solve the same way now. First, this case, solve it. Your P will come, R will come. See, I will change R value. 6 into sine 44 equal to, sorry, I should make a note here. 0 to 7.713. I want it later. 7.713. Okay. I will explain. Okay, then here P will come. R will come. Right. This pen cap problem. Okay. Done. How much it is? 6 into sine 44 will come 4.1680. I noted down there. Yes, correct. 4.1680 kilonewton, and your P will come 4.1680 into cos 44. No, sorry. 4.8610, 4.1680 into 0.8391. That one you subtract from 6 into cos 44. 0.819. P will come plus 0.819 kilonewton. Okay, I will note down here. 0.819. 819. And second case solve. Now friction reversed here. Same way solve. This will come same as that answer. How much? 4. You solve it. 1680 only will come, but P will change. P will come. Oh, sorry, I change. See, I not change it here. This is 46 degrees. This is 44 degrees. So 4 point is there. 4.1680 into 0.8391. To that one you have to add 6 into cos 44. Why add? You don't bother. You don't think of these shortcuts all. I can imagine. I will tell to prevent, to move it up, it has to overcome. No, sorry, you don't have to add. You have to subtract. You have to add now. See, 4 point, how much it is? 1680 into 0.8391 friction. Now you have to see, there your friction is helping you. Here you have to overcome the friction also, and also gravity. You never do this one. Plus 6 into cos 44. 7.813. This P will come plus 7.813 kilonewton. Therefore, right, for equilibrium, range of P is what? P is plus how much? Plus 0.819 kilonewton to plus 7.813 kilonewton. This is the answer. Or minimum value of P for equilibrium is 0.819 kilonewton. Maximum limit for P for equilibrium is 7.813. 1 minute now. 0.683. This one is 0. 7.713. Correct answer? Yes, correct. This is 0.8192. 7.813. Sufficient. 7.813. Okay. Question is completely solved. Now I will tell you the real concept. Real concept. Actually, this class, those who want to understand thoroughly, next to what I am telling is the most critical part. I may give some money matter example also. I may give, okay, depending on situation. Now, I will conclude by telling the logic. See, correctly understand. This is 35 degrees. See, for all the three cases, angle of friction is 40 degrees. Tan 40 is your mu. That is how much answer? 0.8 something. I don't remember how much it came. Who will remember values? Tan 40. Tan 40 is 0.8391. Okay. That is not required for us now. So, mu is same. Okay, now, see, 35 degree angle, little more stiff, 40 degree angle, further more stiff, 46 degree angle. See here, I will explain with a model. What happened here is, case 1, 35 degrees, if you know the basic principle, this angle is less than angle of friction 40 degrees. You can make a note if you want. See, those who want to understand correctly can make one extra note there. Where is the pen I kept? I don't know. Somewhere I kept it. Here, okay. Some extra note you can make here. See, you can make here case 1, see, to understand, this is your theta. This is your theta. This is your theta. So, you can make a note here, extra note. See, extra note. One extra note. One extra note. This is logic. We proved it. What? Theta is less than phi. Phi is 40 degrees. Theta is 35 degrees. Theta equal to phi. Theta is 40 degrees. Phi also 40 degrees. Theta is more than phi. Theta is 46 degrees. Phi is 40 degrees. This only will tell you that this case, A, you can write here, we know the principle. See, when a body is placed on inclined plane, as you increase the angle, till your angle becomes equal to phi, it will not slide. When the angle becomes equal to phi, it is on the verge of sliding down. Therefore, this question, theta is less than phi, it is stable. It is stable. Therefore, to move it down the plane, you require some effort. See, this way. See how much answer? Oh, sorry, minus 0.683. Yes. Oh, yes, you got minus 0.683 because you are applying a force this way. So, to move it down the plane, it is already stable. You require a force this way. See, you have to require a force this way. That's why negative sign came. You can apply a force like this. Then at 0.683, it will start sliding down. And to push it up the plane, 7.566. This is calculated. See, to push it up the plane. Okay, now, here, your theta is exactly equal to phi. That is, the body is already on the verge of sliding down. So to prevent sliding, to prevent it from sliding down, you don't require any force. Why? It is already on the verge of sliding down. But to push it up the plane, you require little more effort. You require what? 7.713. Little more effort because angle is more. See, when the angle is more, effort required is more. This question, theta is more than phi. So this body is not in equilibrium. It will slide down. To prevent sliding, you require a force like this. So if you apply a force of 0.819, it will prevent the sliding. And if you increase the force to 7.813, it will start moving up. Okay. Now, This logic you can make out. Or this negative sign means you can apply the force like this also. Okay, now I will tell easy example for you. See, correctly see. Imagine a road. Money matter is not required. Road. Little inclined. What angle inclined? 35-degree angle. Brakes on. Front brakes on. Vehicle is, we don't know. This case, the vehicle is already stable. It is not sliding down. Therefore, if you want to slide down, you require a force like this. That's why P came negative. Of course, to move it up the plane, you require same way force. So negative to positive. This is the case when you see the vehicle is on the verge of sliding down by miracle standing. See, somehow you can see it slightly wobbling. See, you can see it. When you go near it and touch it, you can feel the wobbling. Why? It's on the verge of sliding down. So, to prevent sliding, you don't require force. But to move it up the plane, you have to overcome friction also now, 7.713. This case is the case when vehicle is placed on a rough inclined plane where it is actually, after you apply the brake and driver goes, the vehicle will start sliding down. So to prevent the sliding, now you require a force. How much? 0.819 to prevent the sliding. Then after preventing sliding, if you want to move the vehicle further up, you have to overcome the friction, increase the force to 7.813. Therefore, this question from minus 0.683 means this way, see downside 0.683 to this up the plane 0.756. If you apply any force, it will be in equilibrium. It will neither slide down nor move up here. If you apply any force above 0 but up to 7.713, body will be in equilibrium. It will not slide down and it will not go up here. If you apply a force 8.819 to any force between these two, see, if you apply less than 0.819, it will slide down. So any force you apply between these two values, body will not slide down and also it will not move up. So completely concept. See, this is how you learn the subject. Remember, concept. Little dark, wet actually, because I rubbed with the wet cloth. Okay. Red color I will put. Red means important. What I told today is concept. Concept, principle, or what you can tell is fundamental concept, or important information, or basic principle. So this way, if you study and understand not only friction, every subject now onwards, see every chapter now onwards, not here, friction leave it now. When I start strength of materials and structural analysis, this way if you understand, it will be firmly in the mind. See, any day, anywhere walking, I am going somewhere. Whatever I am doing, people know. You ask me any question on engineering mechanics, strength of materials, structural analysis, determinate or indeterminate, RCC, steel, pre-stress concrete, finite element method or matrix method, some more subjects are there. Whatever you ask, even software also, ETAB and SAFE also. Any question asked any time, I will tell the answer immediately. Immediately, I will not tell, let me come tomorrow, let me see, let me check it, nothing like that. I am not boosting myself. I got that capacity. Now, you should know how I got that capacity. Every concept is firm in the mind. It is, blood has absorbed it. It is in my blood. See, people tell, it is in the blood. It is in the blood only. That's why I told, spelling mistake, rare case grammar mistake, or sometimes due to some reason, my calculator is not good working condition, calculation mistake possible. But I told, technical mistake, no, impossible. As long as I am in good state of mind, technical mistake is not possible. I am not boosting myself. What I am telling is, this is to give you inspiration. My students know it. This is to give you inspiration. Oh, you can reach any height. I don't want to tell my height now. I don't want to tell. Any height, unlimited height, you can reach in a subject knowledge and a design principle also, provided all this concept you understand. Okay, hope now onwards more and more people, after seeing this one, at least more and more people will start watching. Again, I told you to see, I am right now engineering mechanics. Later strength of material, I know strength of material structures, more and more people will watch, I know it. But this also engineering mechanics, friction is not all that important. But that forces and then moment of inertia, centroid, that equilibrium, that all very, very important. So that type of loads, how to find moment, so many things we considered. Class number is reaching 300 now in engineering mechanics. Another 35 or 40 class will be there, around 25 to 30 class will be there for friction. Once I finish that one, I will go to strength of materials. So, I can't tell request, okay, somewhat request only, because even I also want to be recognized. My effort, I know I should be recognized. So, share and pass on the information to many, many people. And one more thing, always go through entire class. Don't see like a entertainment video. See, like, oh, today class uploaded. I will tell there. See, today we will find, okay, next. What next? Where you are studying? Then, oh, over. Okay, finish 1 minute. Okay, over. The way you see some in the YouTube uploaded videos, if you are not serious, what you do? You move here, move here, move here, move here, move here, over. You should not put your finger on that scrolling one. Let it start from beginning and end. Make a note. In between, when requirement is there, pause to write the notes. Unless you go for the notes from my side, for which I already told you. Okay, now I'll continue in the next class. Thank you for going through everything. And once again, I hope more and more people will start learning structural knowledge from me now onwards. Okay, thank you.